Hello everyone and welcome back. My name is Mr. Cobalt and in this video I'm going to be going over more Lewis dot structures. So I've got a few to go through as you can see. So I'm going to try to go through these quickly in this video and following the steps. So again, following the steps will guarantee that you get the right Lewis dot structure as long as you follow the steps, right? So let's get into this. So first we have CCl4. Again, the first step is to write out the number of valence electrons. So carbon has 4 valence electrons, so we're going to add 4. And then chlorine is in group 7, so it has 7 valence electrons, and we have 4 of them. So 4 times 7 is 28. And so we add those together and we get 28, not 21, 28. And we get 32 electrons, valence electrons total. So that's the first step. Notice that we don't have any charges, so I don't have to worry about adding electrons for negative charges or taking electrons away for positive charges. So that's the total number of valence electrons that I have. Now, second step is the skeletal structure. Again, for this central atom, it's usually the first atom in your formula. It's going to be the lesser electronegative atom. So carbon here is written first. It's also the lesser electronegative atom. Carbon also has more bonding power, if you will. So it's able to bond more than chlorine. Chlorine likes to bond once with one valence electron if you draw the Lewis symbol. Carbon will have 4 unpaired electrons if you draw its Lewis symbol. And another thing I didn't mention before is that if usually the central atom is the one that you will have fewer of or one of. So you'll see here I have 4 chlorines. I only have 1 carbon. So carbon is very likely to be your central atom. So we're going to do our central atom. I'll draw it here. So here, the carbon, and then I'm going to bond everything once with to the carbon. So we have Cl, 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 Cl. So there's my skeletal structure. I used 4 bonds, so it's 2 electrons per bond. So I'm going to subtract out 8 electrons, and so that gives me 24 electrons left. Okay, so now step 3. Step 3 is add lone pairs to your outer atoms to give them an octet if they need one. So all the chlorines do need an octet. So I'm going to add 3 lone pairs to each chlorine. So this is 1, 2, 3, 1, 2, 3, 1, 2, 3, and that's it. Okay, so now that I've added the electrons, I got to subtract that from my total. So I have 4 chlorines. I added 6 electrons each. So 6 times 4 is 24. So I subtract out 24. And I have no electrons left over. So at this point, you check your Lewis dot structure to make sure everyone's happy. If all the atoms are happy with an octet or whatever number they're happy with, then you're done. So you'll see here that, as I mentioned, each of the chlorines have an octet. You have to check the central atom. That's usually the one where we run into issues. So if you look at the central atom, carbon, it has 4 bonds. That fits the bonding pattern. Also, 2 electrons per bond. That's 8 electrons. So carbon is happy. So this is our Lewis dot structure for the first one. Okay, what about Cl2O? So again, first thing we want to do is add up the valence electrons for this molecule. So we have 2 chlorines. The chlorine is in group 7, 7 valence electrons. Therefore, 7 times 2 is 14. And then we have 1 oxygen. Oxygen is in group 6, so that's 6 valence electrons. So we're going to add 6 to that, and that's going to give us 20 valence electrons. Again, no charge, so I don't need to worry about adding and subtracting. Now, next one is our skeletal structure. So we need to determine what the outer atom is. Now, I've said before that usually the first atom in your formula uh, is the essential atom. So here we have chlorine, but chlorine is not going to be the essential atom in this case, because if you think about the other factors we should think about is the essential atom is going to be the lesser electronegative atom. So if you compare oxygen and chlorine in their electronegativity, chlorine is going to be more electronegative than oxygen. Also, one of the things you want to think about is the number of each one. So I have less oxygen, but I have more chlorines. Also, if you look at the um, number of bonding power, right? So if you do the Lewis symbol for oxygen, you have two unpaired electrons, so it's going to bond twice. But chlorine only has one unpaired electron, so that would bond only once. So it's all going more towards the oxygen. So your oxygen in this case is going to be the essential atom. Okay, so now we're going to bond oxygen. So oxygen is going to be our essential atom. And so we're going to bond the chlorine to our essential atom. And so this would be our skeletal structure. I think I misspoke earlier. So oxygen actually is more electronegative than the chlorines technically, but because of the bonding power and the fact that we have more chlorines, that's going to move That's going to move us to choosing oxygen as the central atom. So we got our central atom, we got our skeletal structure. So that we're done with step 2. So we have to subtract the electrons. So that's going to be 4 electrons, 2 for each bond. Subtract out 4, and that's going to be 16 electrons left. So again, the step 3 is add lone pairs to your central atom. Add lone pairs to your outer atoms first to give them octets if they need it. So the 2 chlorines will definitely need lone pairs. So we'll add 3 lone pairs, this chlorine, 3 lone pairs to this chlorine. So now each chlorine is happy with an octet. So we're going to subtract out 6 here, 6 here, that's 12. So we're going to remove 12, and that's going to give us 4 electrons left over. So we are done with step 3. Step 4 is if you have electrons left over, they're all going to be put onto the central atom. So as electron pairs. So I have 4 electrons left over. That's 2 electron pairs. So I'm going to add that to oxygen, the central atom. So I used up my 4 electrons. So no more electrons. So now I double check my Lewis structure to see if everyone's happy. The chlorines are happy with an octet. Oxygen, again, the central atom is usually going to be the problem. But here we have 2 bonds, 2 lone pairs. That's 8 electrons. Oxygen has its own octet. And notice that the bonding pattern fits, right? Oxygen loves to have 2 bonds and 2 lone pairs. So here is our Lewis dot structure for Cl2O. Okay, next, ClF2. Again, we want to do the first step, which is to add up all the valence electrons. So again, carbon is in group 4, so that's 4 valence electrons. Plus oxygen, oxygen is in group 6, so that's 6 valence electrons. And fluorine is in group 7, so that's 7 valence electrons. I have 2 of them, so it's 7 times 2 is 14. So I add that together. 14 and 6 is 20, plus 4 is 24. So I have 24 electrons to use for my Lewis dot structure. So now step 2, skeletal structure. So here I have carbon. Carbon is written first, so it's likely to be the central atom. Oxygen and fluorine are more electronegative than the carbon. Also, carbon bonds more, makes more bonds compared to oxygen and fluorine. Fluorine is only going to bond once. So like hydrogen, fluorine will never be a central atom. So if you have fluorine in your molecule, just like hydrogen. Ignore it. It's never going to be a central atom. So between carbon and oxygen, carbon would be the central atom here. So if we draw it up here, so I have carbon, and then the oxygen and the fluorines are going to be bonded to the carbon. So I have a fluorine, and oxygen. So that step 2 is done. So I need to subtract out the electrons from the bonds from my total. So that's going to be 2, 2, and 2. That's 6. So I'm going to subtract out 6, and that's going to leave 18 electrons left. Step 3, add lone pairs to your outer atoms to give them an octet if they need it. Oxygen, fluorine, and fluorine all need an octet, so they need lone pairs. So that's 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so now they all have an octet. I used up 18 electrons, 6, 6, and 6. So I'm going to subtract that out, and I have no electrons left over. So now I look at my Lewis dot structure at this point and make sure everyone is happy with an octet if they need it. So oxygen, fluorine, and fluorine, they all have an octet because they have 3 lone pairs and 1 bond. Carbon, the central atom, again, if there is a problem, it's going to be the central atom, and here we have a problem. So we have 3 bonds, that's 6 electrons. Carbon would like to have 8, but we don't have any more electrons to give, so we got to go to step 5. Step 4 would be if I have electrons left over, then I would add my lone pairs. I would add them to the central atom as lone pairs, but I don't have anything to give. So I got to skip step 4 and go to step 5, which is move electrons from your outer atoms to create double bonds. Now, you might think that you can move electrons from the fluorines and create a double bond, like so. You might think, oh, I'm going to move this electron and I'm going to create a double bond there. Now carbon's happy with 4 bonds, done, right? However, this would be bad because fluorine is not going to bond more than once. It's only going to bond once. It's not going to form a double bond, so that's not going to be possible. So the only possibility would be the oxygen. And notice, again, the bonding pattern is that oxygen loves to bond twice. So it likes to have 2 bonds and 2 lone pairs. So oxygen fits the bill. So we're going to take a lone pair from oxygen. We're going to create a double bond. Now the carbon has 4 bonds. It's happy with an octet. Oxygen still has an octet, 2 bonds, that's 4, plus the 2 lone pairs, that's 4. 4 plus 4 is 8. So oxygen is happy. So we're done. So this is the Lewis dot structure for COF2. Let's keep going. So D, we have C2Cl6. So again, let's add up our valence electrons. So I have 2 carbons. That's going to be 4 times 2. Carbon is in group 4. So 4 times 2 is 8. So I have 8 valence electrons here. 8 valence electrons from the carbons. And I have chlorine. Chlorine is in group 7, but I have 6 of them. So 6 times 7 is 42. So add those together. I have 50 electrons to use. Whew. Okay, so now we have to set up our skeletal structure. So again, our central atom is going to be carbon. It's written first. It's lower in electronegativity. It bonds more. And notice I have more chlorines compared to carbons. So it's going to be our central atom. So we have 2 of them. So that means we're going to have 2 central atoms and they're bonded together. So we're going to have carbon bonded to carbon. And then we have these 6 chlorines. We're going to divide them up on each of the carbons. We like symmetry. Symmetry is the name of the game. So if you can be symmetrical. Here we have no choice because we have 6 chlorines and we got to put them somewhere. And so it just ends up being 3 on each carbon. Okay, so now that I have that done, I'm going to subtract out the electrons. So I have 1, 2, 3, 4, 5, 6, 7 bonds, 2 electrons each. That's 14. So I'm going to subtract out 14 electrons, and that's going to be 36. So I have 36 electrons left over. Now for step 3, add electron lone pairs to your outer atoms to give them an octet. So I have 6 chlorines. All of them need an octet, so I'm going to add 3 lone pairs each. So each chlorine is going to get a lone pair, like so. 1, 2, 3. Okay. So everyone has an octet. All the chlorines have an octet. So I'm going to subtract out the electrons I used. So I have 6 chlorines. I used 6 electrons each. 6 times 6 is 36. So I'm going to subtract out 36. And I have 0 electrons left over. At this point, I double check to make sure everyone's happy that needs an octet. So the chlorines all have an octet because we just made that so. Now what about the carbons? The carbons here have 1, 2, 3, 4 bonds for this one. That's an octet. 1, 2, 3, 4 for that one. That's an octet. Everyone has an octet. We're done. That is our Lewis dot structure. Okay, next one. So E, BCl3. So again, got to add up the electrons. Boron is in group 3, so it has 3 valence electrons. We only have 1, so that's 3. And we have 3 chlorines. Chlorine is in group 7, so 7 times 3 is 21. So add that together, you get, oops, not 30. You get 24. So 24 electrons to work with. Second step, skeletal structure. So here, boron is written first, chlorine second. Boron is lesser electronegative. We have more bonding that goes with boron. Boron has 3 valence electrons, 3 unpaired electrons, so it's going to bond 3 times. Chlorine only once. And we have more chlorine. We only have 1 boron. So boron is going to be the central atom. So here we have B for boron, and we're going to combine and we're going to add the chlorines, 1 bond each. And so we're done with our skeletal structure. So that's step 2. We're going to subtract out the bonds, the electrons from the bond. So that's going to be 6 electrons, 2 for each bond. So 6, and that's going to give us 18 electrons left over. Okay, at this point, we need to add, so step 3 is add lone pairs to your central atom to give each one an octet if you have electrons left over. So we do have electrons left over, so we're going to give chlorines an octet. So they're going to each get 3 lone pairs again. So now that the chlorines all have an octet, now I'm going to subtract out the electrons I used. I used 6 for each chlorine, so I'm going to subtract out 18. And that means I have no electrons left over. So now I need to double check to make sure everyone's good. So here we said that the chlorines all have an octet, so they're good. What about boron? Boron has 3 bonds. That's only 6 electrons. So you might think, oh, we need to give boron an octet. We don't have any electrons left over, so we can't go to step 4. Step 4 is add if you have electrons left over, add all of them to the central atom as lone pairs. But we don't have any electrons left over, so we can't do that. So we got to go to step 5, and then we would move electrons from the outer atoms to create a double bond that would give boron its octet. Now here's the problem. Chlorine only likes to bond once as an outer atom. So we're not going to draw double bonds for chlorine. That's not going to happen. Right? So we can't do that. So what's the problem? The thing is, with boron, there is no problem. Boron is one of the exceptions to the rule. Boron loves to have 3 bonds. So boron is happy with only 6 electrons, 3 bonds. So that is the case with boron. So you just have to remember that. Okay, next we have N2H4. N2H4, do I have space? Yes, I do. So for N2H4, again, the steps, gosh, you guys are probably getting tired of it, but it's important, the steps. So step 1, add up the valence electrons. You have 2 nitrogens. Each nitrogen has 5 valence electrons because it's a group 5. 5 times 2 is 10. We're going to add to that the hydrogens. Hydrogen has 1 electron, 1 valence electron, so it's going to be 4 times 1 is 4. Add that together and you get 14. So I have 14 electrons, 14 valence electrons to work with. Now here again, hydrogen is never going to be a central atom. So your central atom is nitrogen. We have 2 of them. So we have 2 central atoms. So we're going to bond the nitrogens together. Like so. And then we're going to bond the hydrogens to the nitrogen. Symmetry is good here. Always follow symmetry if you can. So we're going to bond 2 hydrogens to each nitrogen. So we're going to do something like this. Okay. So now we have our skeletal structure. So now we're going to subtract out the electrons from the bonds. So we have 2, 4, 6, 8, 10. So we're going to subtract out 10 electrons, and then we're going to have, 4 electrons left over. So step 3 is add lone pairs to your outer atoms to give them an octet if they need it. But notice that all of our outer atoms are hydrogens. They don't need an octet. They're fine with 1 bond. So we can skip that step. So step 4 says if you have electrons left over, you can add them to your central atom. In this case, we have 2 central atoms and we have 4 electrons. So we're going to add those as lone pairs. And again, we're going to split it apart. So we're going to put a lone pair on this nitrogen and a lone pair on that nitrogen. And so now we used up those 4 electrons. So we have no more electrons. So at this point, we double check our skeleton, our Lewis dot structure. Sorry, I can't speak today. And we're going to make sure everything's okay. If everything's okay, then we're done. So we look here. The hydrogens are happy with their 1 bond. What about the nitrogens? Do they have an octet? Yes, they do. They have 3 bonds. That's 6 plus 2 for the lone pair. That's 8. So the nitrogens are happy. Also, check out the bonding pattern. So nitrogen loves to have 3 bonds and 1 lone pair, and that's exactly what they have. The hydrogens love to bond once, so we're good. We don't have to do any more. This is the Lewis dot structure. Okay, next. H2O2, same thing. So H2O2, going to do this quickly. Hydrogen, 1 electron, 2 hydrogens, so that's going to be 2 plus the oxygen. That's in group 6, so 6 valence electrons times 2 is 12. And again, we have 14 electrons. Our skeletal structure, again, hydrogen's not going to be a central atom, so it's oxygen. We have 2 oxygens, so they're bonded together. So we'll have 2 electrons and 2 hydrogens. We're going to do symmetry. So 1 hydrogen on each oxygen. So that's our skeletal structure. We're going to subtract out 2, 4, 6 electrons. So we subtract that out and we got 8 electrons left. Now for the step 3, add electrons to your outer atoms to give them an octet. We don't need to do that because their outer atoms are hydrogen. They're happy with 1 bond. So we go on to step 4, add lone pairs to your central atoms to give them an octet, or anything left over, just throw it onto the central atoms. We have 2 oxygens, so we're going to divide up evenly among the oxygens. So we have 8, so that means 4 on each oxygen. So we're going to do 2 there and 2 lone pairs there. Subtract out the 8. We have 0 left over. So now we check our Lewis dot structure. And again, hydrogens are happy with 1 bond. And look at the oxygens. They have 2 lone pairs, 2 bonds. 2 bonds, 2 lone pairs. They have an octet. The bonding pattern fits. So here we go. Oops. Sorry about that. So we're done with this one. So that is the Lewis dot structure for that one. Next we have NH2OH. So again, quickly. So we have nitrogen that's in group 5. So we have 5 valence electrons. We have 3 hydrogen. Each one has 1 valence electron. So that's 3. And we have oxygen that's in group 6. So that's 6 valence electrons. We add that together and we have 14 valence electrons again. So now we have step 2, draw your skeletal structure. So here again, this is a organic molecule. So the hydrogens are going to be bonded to the atom that they follow. So hydrogen is bonded to nitrogen. So this nitrogen has 2 hydrogens bonded to it. And this oxygen follows the nitrogen, so the oxygen is bonded to the nitrogen. And then this hydrogen follows the oxygen, so it's bonded to the oxygen. So there's our skeletal structure. So we have 1, 2, 3, 4 bonds, so that's 8 electrons. I'm going to subtract out 8. That's going to give me 6 electrons left. First, step 3, add electron lone pairs to your outer atoms. So my hydrogens are fine, so I don't need lone pairs on those. The oxygen is an outer atom, so that's going to be added lone pairs. So it needs 2 lone pairs to get an octet. So I'm going to add a lone pair there, lone pair there. That's 8 electrons. So I'm going to subtract out 4 from the lone pairs. That gives me 2 more. And then I'm going to add those to the central atom, nitrogen. And so now I don't have any more electrons left over. So I subtract out 2. I have 0 left over. So now I double check my Lewis dot structure to make sure everyone's happy. The hydrogens are happy with a single bond. Oxygen has its bonding pattern, 2 lone pairs, 2 lone pairs, 2 bonds, so that's 8. Nitrogen has its bonding pattern, 3 bonds, lone pair, 1 lone pair, that's 8. So everyone's happy. So we're good with that one. And then finally, NH3. So really quickly, I'm going to sum up the number of electrons. We have nitrogen is in group 5, 5 valence electrons. Chlorine is in group 7. I have 3 chlorines. That's 3 times 7, so plus 21. And that's going to be 26 valence electrons total. My skeletal structure, nitrogen is going to be my central atom. It's lesser electronegative. It's the written first. I have less of nitrogen. It bonds more. So nitrogen is going to be my essential atom, and I'm going to bond the chlorine to the nitrogen. I'm going to subtract out 6 electrons for the bond. So I have 20 left. So step 3, I'm going to add lone pairs to my to my outer atoms to give them an octet. Chlorine needs an octet, so each one is going to get 3 lone pairs. That's 18 electrons that I use. I'm going to subtract out 18. I have 2 electrons left. Step 4, add all the leftover electrons as lone pairs to your central atom. So I only have 2 left, so that's 1 lone pair. So subtract out the 2. I have 0 electrons left. So now all I need to do is double check. Chlorines have an octet. Nitrogen has its bonding pattern, 3 bonds, 1 lone pair, that's 8. That's the Lewis dot structure. That's it for this video. I hope you enjoyed this video. If you learned from this video, then please like, share, subscribe to my channel, Hit that notification bell when you do. Make sure you click all. And if you have any questions, please ask.